Alright, we're back. Sorry about that. My phone ran out of storage. So anyways, we were talking about this pattern of 2n plus 1 times pi over 2, which indicates every possible point at which cosine equals 0, in which the output of cosine equals 0, and that's what arc cosine stands for. But we really only need to write down a couple. And you can prove this to yourself because, in fact, 2n plus 1, if you plug in any n that is an integer, you will always end up with the next odd number. So that's kind of a useful tip. And these are all the possible solutions for arc cosine of 0, and this is equal to pi t. Well, we're looking to solve for t. T, when velocity is a maxima, we can divide by, or minima, we can divide everything by pi. Divide everything by pi, divide everything by pi. And you'll notice that the pi's cancel here. I'm going to make some room. The pi's cancel, and what we end up with is that t is equal to some set of numbers that includes 1/2, 3/2, dot, 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 all the way up to n plus, or 2n plus 1/2. And we are actually just going to pick any of these and plug them in to our velocity function, because we solved when acceleration equals to 0 to find the time at which max velocity occurs. Let's just take 1/2 and plug it into velocity. So 1/2 for time, that gives us pi times 1/2, that's pi halves. Sine of pi halves is 1, and 1 times negative 24 pi is negative 24 pi. So our velocity max is negative 24 pi. But is it really negative? Not really. We're just going to go ahead and take the absolute value of both sides, and I'll tell you why. It's because, 24 pi centimeters per second is going to be the speed that this block is going through the origin that way, or that way. So in other words, with a sine graph, there's always one amplitude, and you always go up that amplitude, then down that amplitude, up that amplitude. And so it doesn't really matter, because we know that our maximum velocity is going to be equal to the absolute value of the minimum velocity, which is in fact a negative word velocity versus a positive word velocity. So we've solved the first problem. The question now is, where is it when this occurs? Well, that one's kind of nice because we already solved for the time. Let's see, where did I write that down? The time at V max we decided was 1/2, 3/2, 5/2, and so on. And the next question asks us the times at which the cart has a maximum speed. And remember, we're looking at the interval between 0 and 5. So we're looking between 0 and 5 for times that we're going to enter in for a solution. So one of those times is going to be 1/2, one of them is 3/2, one of them 5/2, 7/2, 9/2. What is 9/2? 9/2 is 4.5. So we're not going to include 11/2 in our list. And the reason why is because 11/2 is larger than 5. We're only interested in the times this occurs between 0 and 5 seconds up here. Alright, so need to make some room. I'm going to make some room up here. I think we all get the picture. So we'll get rid of that. And okay, so next question is the position of the cart when it has its maximum speed is blank. So we're going to take any one of these times, right? 1/2, 3/2, 5/2, 7/2, 9/2. We're going to plug it into our position function because it's asking at what position velocity is the maximum. So we're going to plug in 1/2. That's going to give us pi halves, right? 1/2 times pi is pi halves. Cosine pi halves is 0. That means that at position 0, we have our max velocity. And that makes sense, right? Because if you pull the cart back, the spring will pull, 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 pull. It'll keep pulling until it reaches 0. And then it'll go this way and the spring will push, so you'll be decreasing speed. So it makes sense. Like if I took a pendulum and I let it swing, its max velocity is in fact at the bottommost part of the pendulum swing, and that's kind of logical. So that's the interpretation from finding out what position is. So it's going to be 0 centimeters. All right, it says good job. What is the magnitude of the acceleration when the cart has the maximum speed? Well, we know the cart has the maximum speed in these seconds: 1/2, 3/2, 5/2, 7/2, 9/2. So now we just plug in those times to our acceleration function, which we found earlier. A of t equals -24 pi squared cosine pi t. We will now just plug in any one of these will do. We'll plug in 1/2. Cosine pi halves is 0. Woo, we're going to 0 again. Alright. So, in fact, when you have a maximum velocity, you are at 0 acceleration. And that's a little bit counterintuitive. But it makes sense because, like, so imagine that you are falling, right? You're falling and you keep speeding up. So in other words, there's some acceleration acting on you. But when you hit the ground, you have the maximum velocity, but you are now no longer accelerating because you've hit the ground. So that's how I kind of think about it, is your maximum velocity always occurs before your acceleration becomes 0. Alright, so what's next? The position of the cart when the magnitude of its acceleration is a maximum. Alright, this is part B. So acceleration is going to be at a maximum when the third derivative of position with respect to time is equal to 0. So let's get rid of this stuff. And this one's fun. So it's rarely ever used though. It's the third derivative of position, which is equal to the second derivative of velocity, which is equal to the first derivative of acceleration. And what do we call it? We call it jerk. J is a function of t. So let's take the derivative of acceleration. -24 pi squared cosine of pi t. Negative cosine becomes a positive sign, so we have 24 pi squared sine of pi t times pi. Because of the chain rule, we took the derivative of the inner function. That just makes this pi cubed. We're going to set jerk equal to 0 and solve. So we divide that over. 24 pi to the 3 goes away, and we end up with sine pi t equals 0. So we take pi t as equal to the arc cosine, or the arc sine, I'm sorry. It's the sine function, arc sine of 0. And the arc sine of 0 is asking at what points will sine graph have zeros. And if we look at the standard sine graph, sine has an output of 0 at 0, it has an output of 0 at pi, it has an output of 0 at 2 pi, and so on. And so our list here is going to be 0, pi, 2 pi, dot, 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 to any n that's an integer times pi. And that's equal to pi t. We want to solve for time at which acceleration is a maximum, so we'll divide everything by pi. And what we will end up with is, let's move up here, t is equal to either 0, 1, 2, dot, 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 any integer number. Alright, so now at this point, the question is, what is the position of the cart when the magnitude of the acceleration is maximum? So any one of these points represents a time where the magnitude of the acceleration is a maximum. So we just need to plug those into our position, because it's asking what position is it in when acceleration is at a maximum. So we'll plug those in to our position. Let's just choose 0, because 0 is really easy. So 0 as time, pi times 0 is 0. Cosine of 0 is 1. Alright, so 1 times 24 is 24. So our position is 24 centimeters when acceleration is at the maximum. Because if you've noticed, when you stretch a spring, its force increases ever more the more you stretch it back. So if you let go of the spring here, it will indeed have a maximum acceleration. If you let go of it here, it will have a max acceleration here. Because as the spring goes back to its natural form, it no longer has as much acceleration. So this is a correct result. At 24 centimeters, we're going to have maximum acceleration. It says is R, use comma to separate, so I'm guessing it wants 24 comma minus 24, and it wanted that. Okay, so for that part it wanted not only 24 centimeters, but minus 24 centimeters, because at both of those positions, acceleration is at a maximum. Now, what is the speed of the cart when the magnitude of the acceleration is at its greatest? Well, the magnitude of the acceleration at the greatest is at time equals 0, 1, 2, 3, 4, 5. And now it's asking about speed. What is the speed of the cart at these times when the magnitude of the acceleration is highest? So now instead of plugging these into position, we're going to plug them into speed, which is velocity. So let's plug in 0, because 0 is easy. Sine of pi times 0 is sine of 0. Sine of 0 is 0, and so our velocity is 0 when our acceleration is at a maximum. Which is also interesting. It's kind of the opposite of what we talked about, where, when velocity is a maximum, acceleration is 0. Also, when acceleration is at a maximum, velocity is at 0. So those are some interesting things about spring systems. This was a really long video. It's a really long problem. And let me know if there's anything more you'd like to know about this. I was just trying to rush through it. I hope this helped, and I'll see you next video.